Hello everyone, welcome to the session. So now in this video, we'll do the model prediction. So I hope that you remember that in the last video, we are done with the model training part. We have trained our model with the linear regression algorithm and the model name is regression, right? So let's try to do the prediction on the test data now. So what I will do is I'll try to take the model name regression dot predict, and what I want to do the prediction is on the test data, right? So what I will do is I'll try to take the test data and maybe I'll store my predictions in the variable name rig underscore pred. So this will give me the predictions of the test data. So what I can do, I can just try to see what is the outcome we will be able to achieve. So here if you will be able to observe, okay, one thing which I have done wrong is my prediction, my test set is x underscore test underscore norm, if you remember, right? We have taken the normalized data. So let me update this. I think now it is fine, right? So we will be able to get the predictions, which is a, price house, right? House of a price, which we will be able to get there. Now, what I can do here is, if you remember, when I was explaining you the concept of linear regression, I have explained you what is the meaning of residual or what is the meaning of an error. Do you remember that? What I have explained you in the explanation part? The difference between the actual value and the predicted value. As it's a supervised machine learning algorithm, we do have the actual y-test data and now we do have the predicted data. So what we will do is we will try to calculate the residual. Let's try to calculate the error, or you can say the residual. Okay, let's try to see how will it look like. So I will take a variable name as residuals, and what I can do here is I will try to get the difference between the value of a y-test and the value of the reg underscore pred where I have stored my predictions. So what I can do is I'll try to run this particular part and we'll try to see how my residuals will look like. So you will be able to observe that for every index number, we will be having some residual value, which is in a negative form, which can be in a positive form, right? To see how will it look like, what we can do is we can try to create a distribution plot of these residuals. So let's try to create a distribution plot of the residuals. Now, usually as per the conditions and as per the assumptions of linear regression, do you remember how the residual will look like? It should be in the form of a normal distribution. The more it will be inclined towards normal distribution, better it means that our model will be trained, right? So let's try to see how this plot will look like. So our way to implement is sns.dist plot. Dist plot will help us to give the distribution plot of whatever data you want to see. For example, I want to see the residuals. And what is the kind of plot I'm looking for? I am looking for KDE, kernel density estimation. So this will give me a plot. And here if you will be, let me just figure it out. Kind is equal to KDE, if I'm not wrong. And the variable name is residuals, right? Let's see again. This plot, the spelling is wrong. Now I think it should be fine. Can you see that we will be able to get a normal kind of a distribution, but there is more inclination in the chart towards the left side. It means that we do have, I can say a lot of, you can say outliers are there, where we will be having a value from -10 to -2 as an error. But the maximum part of our data points belongs to a residual, which is from -2 to +4, if you will be able to observe here, right? It belongs to -2 to +4. So that is the real idea, and it clearly indicates that yes, somehow our model is going in a correct direction. But yes, there is a need to improvise on top of the outliers that we have seen in the population data. If you remember, as of now, I have just shown you how we can detect that. We didn't work upon on improving those outliers or handling those outliers, which I will demonstrate in the upcoming sessions. But yes, there is a lot of scope in EDA. That's why this kind of graph is there. Otherwise, it would be in a proper sense in between the normal distribution, just proper Gaussian based distribution we will be able to get if you have done the EDA in a proper way. Okay. Now, this is done. We will be able to get the predictions pretty well. The next important part which we have to see is the, model evaluation, or you can say the performance of the model that we're supposed to see. Now, in order to see the performance, we have lot many metrics. For example, in the explanation part also, I have talked about what is MAE, what is MSE, what is RMSE, right? Mean absolute error, mean squared error, root mean squared error. Then what is R square, what is adjusted R square? All these things we have to evaluate. We have to see what are the numbers we will be able to get. So what I will do is I'll try to create a separate video for that, where I will try to check upon all the performance metrics that we have. We'll try to see what is the number we will be able to get from there. And finally, in the very last video, I will show you that how we will be able to save this model, so that at each and every time we don't need to, do the re-iteration, retraining again and again. Okay?